Molecular formulas. This video is in a series of videos that covers percent composition, empirical formulas, and molecular formulas. The overall goal of this series of videos was to determine the exact number of atoms of each element in a compound, and that is the definition of a molecular formula. So in this video, we are going to be calculating molecular formula using empirical formula and molar mass of a compound. In this example problem, we're going to be determining a molecular formula. Determine the molecular formula of a compound with an empirical formula of CF2 and a molar mass of 200.028 grams per mole. Now, there are a lot of molecular formulas that have this same empirical formula of CF2. Let's list possible molecular formulas. Okay, so possible molecular formulas. First would be CF2 and any other compound with a ratio of 1 carbon to 2 fluorines. So we can multiply both of these by 2 and get C2F4. We could multiply CF2 by 3 and get C3F6. We could multiply CF2 by 4, C4F8. We can multiply CF2 by 5, C5F10. This list is infinitely long. It can go on forever, but I know that whatever my molecular formula is, it's going to have a ratio of 1 carbon to 2 fluorines. Now let's find molar masses of these possible molecular formulas. So for CF2, we have 1 carbon and 2 fluorines. So I want to take 1, because we have 1 carbon, multiply it by the mass of carbon on the periodic table, 12.011 grams per mole. And because we have 2 fluorines, I want to add 2 times the mass of fluorine on the periodic table, 2 times 18.998 grams per mole. For CF2, we would calculate a molar mass of 50.007 grams per mole. 50.007 grams per mole. Now let's find a molar mass for C2F4. We have 2 carbons, so we need to take 2 times the mass of carbon from the periodic table. 2 times 12.011 grams per mole. Plus, because we have 4 fluorines, we need to add 4 times the mass of fluorine from the periodic table, 18.998 grams per mole. And you would calculate a molar mass of 100.014 grams per mole. 100.014 grams per mole. Now, you can continue down this list all you want. But as I said, this list is infinitely long. There are going to be an infinite number of possible molecular formulas. Wouldn't it be nice if instead of calculating a molar mass for every single possible formula until we get to 200.028, if we can just find some multiplication factor? So let's do that instead. There's an easier way to calculate the molecular formula. You can go through that infinitely long list of possible molecular formulas, find the molar mass of each one of them until you get to this desired molar mass. But there's an easier way. We can calculate a multiplication factor, some small number that we can multiply 1 carbon and 2 fluorines by that would have this molar mass. So we want to calculate a multiplication factor. This multiplication factor is going to be equal to the molar mass of our molecular formula divided by molar mass of our empirical formula. When we plug our 2 molar masses into this equation, we should get a whole number. So molar mass of our molecular formula, this is what's given in the problem, 200.028 grams per mole. 200.028 grams per mole. We need to divide this by molar mass of CF2. That was the very first molar mass we calculated when we were going through that table of possible molecular formulas. That was 50.007 grams per mole. That would be 1 times the mass of carbon from the periodic table plus 2 times the mass of fluorine from the periodic table is 50.007. And this gives us a whole number. This gives us 4. What we just calculated is what number we need to multiply our 1 carbon and 2 fluorines by in order to get to our molecular formula. So I am taking my empirical formula of CF2 and I am multiplying it by 4. So 1 carbon times 4 is 4 carbons, so C4. 2 fluorines times 4 is 8 fluorines, F8. C4, F8. This is our molecular formula. So in this series of videos, we calculated percent composition, then empirical formula, finally molecular formula. So if you watch this whole series of videos, you would see us building up to this point where we are calculating exact number of atoms of each element in a compound. Thanks for watching. If you feel that I've earned it, I ask that you like this video and subscribe to my channel.